thanks for coming. I mean, again, it's a last minute jump in from my part, but thanks to Joe and Factual for allowing me to present. Anyways, just getting back to this, who am I? So I'm a specialist engineer, shop seller, co-organizer for the LA Hadoop user group, organizer for LA HBase user group. I've been working on big data for the past 3 years, 3 years plus in fact, 3 years of that mainly on Hadoop. So what is YARN? I mean, how many of you are familiar with Hadoop over here? Just before I get into YARN, okay, not too many. YARN was basically built out of this problem set that Hadoop provided, especially in the I wouldn't say the current version of Hadoop, which is in production in many places. Factual 2 runs it. I'll be talking about some of the problems with it, but the main thing was that there was problems with it, and a lot of these problems would be seen when you started scaling. And obviously, when you scale, I'm probably talking about scale in thousands of nodes. A lot of people out here, I don't know if you'll ever reach that kind of scale, but for big companies like Yahoo and those Amazon and so on and so forth, reaching those kind of limits are pretty obvious. So YARN came out of this thing like, hey, let's try to build a better version of Hadoop. Hadoop was built sometime around 2006, 2007, and since then the world has progressed tremendously. If you know, Hadoop was actually built on a paper released by Google back in 2003, 2004, and since then Google themselves have also gone way forward. So what Google is doing right now, probably Hadoop is 5 years behind the curve, I would say, because Google is like just way out of the boat in terms of what they're doing. So I think back in 2008, 2009, the folks at Yahoo, they were trying to maintain and support Hadoop 1.0, and there were some issues that came up, and one of the guys, Arun Murthy, to be more specific, when he got a call one night and they asked him to fix the problem, and he was like, why am I trying to fix this problem when I could do a much better version? And that's what happened. He started working on YARN, and for the past 3 or 4 years he's been exclusively working on YARN, and that's where YARN came from. So what is YARN? YARN, it stands for Yet Another Resource Negotiator, or as a recursive acronym you could do YARN application, Resource Negotiator. Remedies, the scalability, shortcomings of classic MapReduce, and more of a general purpose framework of which classic MapReduce is one application. So just to, before I go into that, I mean, if you know about Hadoop or what Hadoop is actually 2 systems in one. One is HDFS, second is MapReduce. HDFS stands for Hadoop Distributed File System. The HDFS is actually mounted on your own file system like a ext3 or so on and so forth, and it runs just based on picking up all the, I would say, advantages of your file system. So it doesn't actually create anything on top, it just mounts itself on top of it. MapReduce is actually the feature that way you take a job, you split it into multiple parts. So if you think about simple things that you take, like for example, you want to delegate a service, you want to delegate a particular task or multiple tasks to users. You can say, let me give all my tasks to this one person, and he will take time to sequentially go through all the tasks. Or you get 10 different people, you give them each a certain number of tasks, and let them go and do the task, and then bring back all the results together. So MapReduce is nothing just but that. You take a task, you split it into multiple parts, and then you bring it back together. Map and then reduce it back. So in Hadoop, MapReduce consisted of 2 things. One is the JobTracker, second was the Tasktracker. The JobTracker, as it says, it manages cluster resources and job scheduling. Tasktracker, basically, it resided on every node, and it just took the task from the JobTracker. So JobTracker was like the manager, and he was the one who was assigning the jobs to the task trackers took each one of his tasks, processed it, and gave it back to the JobTracker. So the main function of the job was allocating the resources and keeping track of all the tasks that have been sent out there. By the way, feel free to ask me questions if you have. So as I mentioned, MapReduce limitations, when you try to scale, there was a limit on how much you could scale in the current version of MapReduce. That limit was about 4,000. Most people here wouldn't even hit that limit. I mean, it's typical because we don't even have that big of a cluster. But Yahoo did, so they were the ones who needed this. Maximum concurrent task is 40,000. Core synchronization in JobTracker. It was also a single point of failure. If your JobTracker failed, basically all your jobs in the queue basically failed. So you basically lost everything over there, and jobs need to be resubmitted by users. Restart is also very tricky due to the complex state. You basically need to capture the state of the JobTracker in what it is to actually restart it and start going from there. So it is a pretty tricky limitation of the current MapReduce. So when YARN came about, they decided to the main bottleneck in classic MapReduce. Oh,
Sorry, maybe I'm the older one who doesn't know this, but with JobTracker, was there any other way to add some fault tolerance, such as like when you say it failed? Does JobTracker use HDFS to store the data? Did it have a database?
Yeah, it did use HDFS to store the data, but the problem is, again, you need to restore to that exact state. There's some, it stores some data into memory when it actually runs, and it's actually storing, using that information to decide where the state of the tasks are, how to recall the task. So you could actually restart it, but it's very complicated. There is some additional features that you see. Not only the data in HDFS is JobTracker stores, plus some additional overhead which you would need to keep track of in some kind of form or fashion. So there is definitely a very complex. It's more complicated to restart it, and you need to know what exactly you're doing to do it. So in my case, I've probably done this maybe once. I tried restarting it. It took me a couple of times to actually get it right. It's not something that happens like quickly, and I was using an older version of Hadoop at the time, so it was even more complicated. So definitely, when you try to do such kind of things, you need to know. It's not something that you as a user would be able. Someone who's more technically oriented, someone who's probably more who knows Hadoop from the ground up can probably do this. So that's something that's a limitation then again, because then you have to rely on one person to go and or just mainly a administrator, someone who knows the system very well. So that's why they say restart is complicated. There's a number of things that are involved in that. YARN wants to make this much more scalable, much more maintainable. So if something does fail, the restart is pretty easy. You can just restart the job. It starts automatically, starts processing from where it actually took off, and then you can process to the end. So definitely there is a much better opportunity for simplicity in YARN than with classic MapReduce. Does that make sense?
Yeah.
So coming back to YARN, so when the main bottleneck with classic MapReduce was JobTracker. That's because JobTracker was trying to do two jobs. It was trying to do resource management as well as job scheduling and monitoring. So in YARN they said that let's split this thing. JobTracker does not need to do both the jobs. So that's what they did. They created a global resource manager, which is basically done for cluster resource, identifying what task available to process the job, and an application master which does job scheduling and monitoring, one per application. Negotiates resource containers from the scheduler, tracking the status and monitoring of progress. On the Tasktracker side of things, basically it's the same thing. The Tasktracker still around, but now they just call it a node manager. New per node slave responsible for launching application containers, monitoring resource usage, and reporting back to the resource manager. The last thing is it maintains compatibility with existing MapReduce applications and users, which is a good thing. So if you're migrating to Hadoop 2.0 or YARN, you don't need to worry about, hey, some of my jobs are in current MapReduce and some of the new jobs will come in, will be running on top of YARN. Is there going to be a problem? But no, they're actually trying to maintain compatibility and ensure their jobs will scale as well as run smoothly between two different systems. So architectural overview, scalability, now from previous limitations of about 4,000 nodes, now we're going up to 6,000 to 10,000 nodes. Each machine can do 16 cores, 48, 96 RAM, 24 or 36 terabytes. You can go up to 100,000 plus concurrent tasks and 10,000 concurrent jobs. I think I was back at Hadoop Summit when Yahoo was talking about their YARN implementation. They were saying they were doing close to about 4 to 500,000 concurrent tasks in their new YARN new YARN clusters. I think Yahoo's only one is completely migrated to YARN. Everyone else is still using classic MapReduce. So differences, I would say fault tolerance and availability, resource manager, no single point of failure, state saved in Zookeeper. So that's the other thing. How many of you know about Zookeeper? Any idea? Okay. So Zookeeper is basically this. It's sort of like a quorum-based journal servers where you can you ask of it a question and it responds based on an odd number of servers that it has. Whereas the majority votes and says, if you ask, hey, who's the president of America, it can give you multiple responses, but the majority will vote on a particular response and they will tell you that yes, it's Barack Obama, for example. Hello?
Excuse
Hello?
me, I was just playing with the volume.
Okay. So in this case, so one of the things that it is found out is that because everyone communicates to Zookeeper at every point of time, just to know, like say for example, people want to know who's the name node, like who's the primary person should I talk to. Everyone always kept a state or kept communication open up with Zookeeper. So there came a thinking that said, if everyone is already communicating with Zookeeper, why not we make Zookeeper more, operational, functional, and let's add more things for it to do. So they said, let's start storing configurations, let's start storing, data, let's storing things that other people can also use when they need. So for example, if for your name node, which is basically your kind of like your master node or your master server, that goes down, and Zookeeper actually keeps track of who are your backup name nodes or your backup master nodes that I can go to. So because it also keeps track of that, it also has configuration information about that node. So if someone actually comes and asks who's that, I can actually not only just give him the person's information, I can give him all the configuration information about that person as well. So Resource Manager just did that. No single point of failure. Your state is saved in Zookeeper. Application masters are restarted automatically on RM restart. Application master optional failover via application specific checkpoint. MapReduce applications pick up where they left off by the state saved in HDFS. YA compatibility, very important. Protocols are YA compatible. All clients can talk to new servers, rolling upgrades. So a lot of features are basically maintaining compatibility with the current version of MapReduce and HDFS. So before I start off, if there's any questions, any thoughts? Okay.
I have one question.
Go ahead.
Several slides back, when you're talking about like what happened when the main program would fail and then would have to be restarted and such. But nowadays the hardware itself is pretty reliable. So what would cause the failure typically?
When you're talking about failure in Hadoop, it's kind of more than just hardware. Let's say hardware does fail and you restart the hardware. The reason that state is very important is because at least in the JobTracker namenode is they actually have all the information about all the task trackers. So if your job does fail, basically who's keeping track of where the tasks are coming, who's keeping track of all the information about the task, how much the task is completed, who coordinates ensures that the task is being fulfilled to its completion. So a lot of the information is stored within the JobTracker itself. There's no kind of backup and other than it's stored in HDFS for some part of it, not the whole thing. So that's why it's a big thing, not just hardware. It's also a lot of it is kind of like, I wouldn't say software, but data format or data part of it.
Consistency? Data can get inconsistent, you mean?
Yeah, it's not inconsistent. Just that when you bring that things back up, part of it is that part of the data is stored on HDFS, not all of it. So when the JobTracker needs to restart its state in the queue or state in the progress, it may not start from exact position where it actually failed. Plus, in a failed state, what happens is the task tracker is continuously communicating with the job tracker. If the task tracker cannot communicate with the job tracker, the task tracker has nowhere to go, so it starts failing by itself. So unless your job tracker restarts, really fast, your task trackers are going to just start dying one by one. So classic MapReduce versus so just to give you a bit of this thing is that at least from my perspective, what I feel the biggest advantage of a YARN, is multi-tenancy, and that's the ability of running multiple applications on the same cluster at the same time. Currently in Hadoop, everything is done through MapReduce. You typically don't have any other option. You cannot run multiple systems like trying to do HBase on top of Hadoop, or running HBase simultaneously with MapReduce is actually not advised in current MapReduce paradigms. That's because HBase and MapReduce actually fight for resources, memory and I/O. So that's one of the big disadvantages. You can't actually run. There are ways to do it. There's tricks you could use to do people actually do it, but it's not recommended, and there is potential for resource contention. So to me, the big advantage, at least from my opinion, is multi-tenancy, is the ability of running multiple applications on the same system. For example, we have Thales, which is a generic framework to run complex DAG, HBase on YARN, Spark, Giraph, Storm, and I'll be talking a little bit about this in a couple of slides. So this is how a sample YARN architecture would be. You have your YARN cluster resource management, HDFS2 reliable storage, and then if you notice, you have you have silos of what do you call applications are running on the same YARN cluster. You have MapReduce, Thales, HBase, Storm, Giraph, Spark, OpenMPI, and other applications out there. So MapReduce no longer becomes the only default application on your Hadoop cluster. It just becomes one specific application. So you can do multiple applications on this cluster. So this is more of a general purpose framework rather than a single single job, single Hadoop kind of cluster framework.
I'm sorry, I think it's probably a dumb question, but to get a comparison between this and the previous Hadoop, what was the architecture before? Was HDFS and then just MapReduce on top, right?
Yeah.
MapReduce and JobTracker?
So MapReduce was on top of HDFS, okay. And there was nothing else. So everything you basically ran as a MapReduce job on top of HDFS. HDFS just stored the data. MapReduce was used to process the data. So if you want to do HBase, you couldn't do HBase. You could do it, but it requires tuning the thing and ensuring that both of them don't fight. So you actually have to change the configuration parameters, assign separate memory just for HBase, separate memory just for a MapReduce. Resource contention, you have to ensure that they're not talking, or if they do talk to the same thing, you got to figure out some mechanism of that they don't access it at the same time.
So most people ran two different clusters, one for HBase, one for...
Exactly, so that is typically the use case. And so with YARN, you don't need to worry about that. Everything runs on the same cluster, everything is siloed off, so everything is taken care of, memory management, I/O, resource, everything is treated off. Plus, it's also kind of like a virtual machine, so each one of these is actually treated as a virtual environment. So they can actually be shut down and restarted, and they'll restart from the state they were in when they actually shut down. So that's another good feature about this. So to me, and from my perspective, what YARN brings is multi-tenancy, and that's one of the big features that I think people in the community have kind of have wanted, or they're trying to achieve. So going a bit more into some of the applications currently done on YARN, Storm. I'm sure some of you have heard about Storm and its real-time capabilities. So the guys at Yahoo, they said that they want to do Storm, and they said they want to use it with their Hadoop version. So they went and said, let's start working with Storm on YARN and how to bring Storm into a more real-time application on top of YARN. So motivations collocating, real-time processing with batch processing. As you know, Storm is used to bring the real-time, or you take subsets of data for real-time data, and then you bring it into your processing environment. You could quickly aggregate your small chunks of data, and then either at some point you do MapReduce, you do a full-scale batch MapReduce, and combine the data for all of that. In this case, by bringing Storm on YARN, you actually bring the data closer to each other, so you don't have two separate clusters for that. You don't have a Storm cluster, you don't have a YARN cluster. You have both running on one, so that means network transfer is much smaller, so it's faster to move the data, which is why they wanted to do it in the same cluster. Provides a huge potential for elasticity, reduces network transfer rates, moving Storm closer to MapReduce. So currently Yahoo does implement Storm on YARN, and just to give you an example of how they do it, they have an input file, they have the regular batch processing via Hadoop, and then they have shared storage, and then if you notice, they do all this low latency processing on Storm, and they have it actually in the same cluster, the same HDFS cluster that they use, and everything is done on YARN. So that way they can ensure that data is quickly absorbed by Hadoop on the other side when Storm processes hit. So some of the features that Yahoo did with Storm was it enhanced Storm to support Hadoop-style security mechanisms. It's also being integrated into Hadoop YARN for resource management. So instead of Storm having its own nodes or own, I would say, containers for resource management, Storm will actually use the resource manager of Hadoop. So that way there's no redundant or duplicate systems doing the same job over there. Storm on YARN enables Storm applications to utilize the computational resources in thousands of Hadoop computation nodes, and they are also used to launch Storm application master on demand, and enables members to request resources from Storm application slaves. So they call the application master members, and their slaves are supervisors. So this is just to give you an example of how far Storm on YARN is and how far Yahoo is taken YARN to. I think Yahoo, since they're the biggest deployment of Hadoop out there, they currently have, I would say, about 40,000 nodes on YARN. That's just one cluster. Prior to this, they weren't they weren't able to scale to those kinds of volumes. They actually had multiple clusters of thousands of nodes. Now they actually have 2 or 3 clusters of tens of thousands of nodes. So the scalability of YARN is much more higher than that of what classic MapReduce was. Next I'm going to talk about is Tez. It's in Hindi, it means speed. It's currently in development, but it's going to be released in the next month or so and going to go GA. The basic thing about Tez was basically, one of the big things about Hadoop. If some of you are familiar with Hive, which is a SQL kind of interface towards Hadoop, it had a lot of issues. One of the big things with Hive was that it actually took any query that you wrote, it converted that into a DAG, a directed kind of graph or a execution program framework, and converted that into Java code or Java MapReduce, and then ran it on your MapReduce. So Hive was never real time. It took a lot of time to run these queries, a lot of time to process the data and come back with the results. Tez was actually, they said let's try to make Hive more efficient. One of the big problems with Hive, when it created its execution plan, and if you looked at the execution plan, you will notice there are a lot of redundant parts, and some things were not really needed. So Tez was initiated to say that let's try to make Hive more efficient in how it creates its execution plan. And just to show how it does, if you notice over here, this is on the left side is what currently it would do. So you would see creating multiple jobs. Of that, the output goes towards the second intermediate layer. The output of job 2 then would go to the intermediate, and there again it would combine from create another new job, and you have another third job just to combine the data from the 2 jobs 1 and 2. In Tez, the necessity for creating this intermediate layer or the third job was not required anymore. You could just directly get the output from job 1 and 2 and combine it and bring it into this into the place that you want for reading or accessing and doing further processing.
Excuse me.
Yeah.
TIS is a replacement for Hive, or is
It-
it just
it's not a replacement for Hive. The Hive will run on top of these. So it will make Hive much more efficient in the way it does its execution plans. So you should expect faster response times. So provides a general purpose, highly customizable frameworks that create simplified data processing across both scale and small scale, large scale workloads in Hadoop. Generalizes MapReduce paradigm to a more powerful framework, enables high peak cascading to meet requirements for human interactive response times. So some of the things, performance gains on MapReduce eliminates a replicated write barrier between successive computations, eliminates job launch, overhead of workflow jobs, extra stage of MapReduce. I mean, in basic, what this says is that it's made the execution plan much more efficient. That's more or less, it talks about that queue, resource contention, software. All of this was part of the current MapReduce framework, and all of this you could see when you look at the execution plan. So the one of the things with Hive, there was actually this big initiative to make Hive much faster. It is called the Stinger Initiative. It was divided into 3 phases. Phase 1 has already been implemented as part of Hive 0.11, which is integrating H catalog into it. Phase 2 is basically part of YARN, which is stays and should make Hive much more faster. You could go online and do look up the articles. There's lots of articles talking about these. And phase 3 is actually making it much more real time in terms of how it responds to your queries. And that, I think, is probably maybe 3 or 4 months down the line. Next I would talk to you about is HBase on YARN, or it's called HOYA. It's another prototype, but as I mentioned before, HBase and current MapReduce do not play very well together. You could actually make them play well, but it requires complicated configuration management. You need to understand what you're doing, create memory allocations, I/O allocations for both HBase and MapReduce, and play around with the number of MapReduce tasks. You need to set your JVM child mappers onto how much memory you're going to use on the MapReduce side to ensure that HBase has some sufficient amount of memory to play with. With HBase and YARN, it's completely different. As I mentioned, it's kind of like a virtual environment directly built as on top of Hadoop. It can start and stop at any point of time. Bless you. Start and stop at any point of time. It's treated as its own application on top of the framework. It does not require any kind of special resources for it. So you're able to configure different HBase instances differently. For example, different configs for read-write workload instances, better isolation. Excuse me. So you can run arbitrary co-processing in user's private cluster. User will own the data that the HBase daemons create. Other things is MapReduce job should find it simple to create transient HBase clusters. Map-side joins per table is all in HBase. For example, elasticity of clusters for analytical batch map workload processing. You can stop, resume, start clusters as needed. You can expand, shrink your clusters also as needed, and be able to utilize cluster resources better. Run MapReduce jobs and maintaining HBase's low latency SLAs. So coming back to the big advantage. I mean, as I mentioned before, multi-tenancy is the biggest advantage, and that's what I see. It's going to be a big use case out there right now. You can actually start testing it. It's the beta version of it has just been released August 25th. So you can actually start playing with YARN and try testing it out, and try different things on it. Couple of things I also want to mention: Hadoop 2.0 and YARN. The big difference between Hadoop 2.0 and YARN is Hadoop 2.0 also includes 2 features. One is called high availability, second is called federation. I don't know how many of you know, but currently Hadoop used to have this problem of the name node being the single point of failure. So the name node is actually or you can call it the master node that kept track of where the data was located on all your data nodes. So if your name node went down, basically no one knew where the actual addresses or the space or the data locations of all the data is in all the data nodes, and that was one of the biggest problems with current Hadoop. High availability was basically built to fix this problem. So with high availability, there's actually a backup name node server, and the way it works is that they have it's kind of like Zookeeper, but you can actually run it on top of it. But they call it the QuorumJournalNodes, and it acts in exactly the same way. Basically, if your master node goes down, you ask your QuorumJournalNodes, hey, who's my backup name node? And because the backup name node is always kept in sync with the master name node, it can actually tell you that, hey, this is your new backup name node, and the backup name node can immediately take over and start processing and doing things from the very state that your current master name node was in. And the great thing about it is everything is in your master name node, right down to whatever is even in memory is actually stored in the backup name node. That's because everything that happens in your master name node first is written to disk and then pushed into memory. So that there's always a copy of your HDFS data, which is why it's always available for your backup name nodes to pick up from and restart and move forward from there. So the second feature about Hadoop 2.0 is federation. Federation is basically creating namespaces within your cluster, and this is a lot of it is based upon when you're doing it in the cloud, you want to create different namespaces, and especially if you're doing Hadoop as a service, it kind of makes more sense. You can have different namespaces for different clients or different users. You can also do private public namespaces if you want to have that. So those are two big features. So YARN without Hadoop 2.0 is YARN plus these two additional features, and if you exclude federation and high availability, Hadoop 0.23 is basically what you are left with, because Hadoop 0.23 is the version number for YARN, and when you add the two and you get, add all three together, you get Hadoop 2.0. So that's what it says. So Hadoop 2.0 includes YARN, high availability and federation. High availability takes away a single point of failure from name node, introduce the concept of QuorumJournalNodes to sync edit logs between active and standby name nodes. And federation allows multiple independent namespaces. So about 2 or 3 days ago, Hadoop 2.1 beta was released. So this is a big monumental achievement in the community, because this means that within a couple of weeks or in just over a month, Hadoop 2.0, Hadoop 2 GA goes live, which means it's the most stable release out there, and people can actually start being confident and actually start using or building things on top of it. So features that have been released right now is 2.1 beta, API and protocol stabilization, binary compatibility for existing MapReduce applications, support for Microsoft Windows. So I don't know if you know, but Hadoop for a very long time was only Linux based. There was a little bit support for Mac, but primarily for Linux. I think about 6 months, about a year ago, Microsoft started working with Hortonworks and creating a Windows specific or Windows compatible version of Hadoop, and they have already released the Windows compatible version for Hadoop 1.0, and now they with 2.0 they also will have support for Windows built in. HDFS snapshots. If I'm familiar with snapshots, is basically doing just-in-time backups of how your data look like in that period of time. So you can specify certain number of days to go back and actually look at how your data was at that point of time. Obviously, bless you. Obviously, that comes with some kind of some kind of penalty, because it does take up space on your disk, and depending on how much space you have to configure it and specify how much you want to keep up to. NFS version 3 access for HDFS is available in 2.1. Client APIs for YARN application developers, integration testing. So 2G is expected mid-September and will be tagged most probably as Hadoop 2.2. So that's it from my end. Any questions on this? Guess we have Go ahead.
Yeah, I wonder if you could talk a little bit more about the multi-tenancy in terms of use cases. I mean, I can imagine use cases for myself, but I'm wondering for you what more typical use cases are. And is it basically the idea that you want multiple people to be able to securely share the same cluster? Is that your?
Yeah. So I mean, to me, it's basically can I run multiple applications on the same cluster? I want to share my resources. Like, say for example, if I'm running HBase and Hadoop, sometimes I would like my HDFS data to access HBase data. Sometimes I want my HBase data to access HDFS data. I should be able to do this without having to move data back and forth between two different clusters. That's the one thing. Second thing is HBase is very a memory resource hogger, because HBase it's a real-time kind of database. It needs more memory. It stores a lot of data into memory. It pulls data. It quickly has to pull data from disk, load that into memory. So it kind of creates this resource contention. Whenever you run a MapReduce job, if you notice, it depends on how many mappers and reducers you can fire off at the same time. You can specify that configuration, but sometimes you can create a big job. You can say, go and give me the average sum of all my data going back 3-4 years. And if you have like terabytes and terabytes of data, that means you want to max out all your number of mappers, reducers that you're running simultaneously at the same time. So that means you want to use all the resources available to it, which means that if you have not properly allocated your memory, you probably will be using all of your memory just for MapReduce. And because HBase is more of a real-time system, they'll probably be clashing for resources simultaneously. And a lot of times you'll find that the HBase cluster just dies, and you don't even know why it's happening. And it's almost when you have to actually look at your resource and see your mappers and reducers, you'll actually see that all your memory is being utilized by your MapReduce jobs, and nothing is being available for HBase. So in multi-tenancy, that's not going to be a problem. So HBase has its own set of resources, MapReduce has its own set of resources. Yes, both of them can access HDFS at the same time, but then there is also a lot of checks in place, because HDFS actually does 3 copies of data. Both of them don't access the same data points at the same time. They can access any 3 different versions of the data. So there's the chance of them asking for the same data is very minimal, just because they have multiple copies of data. So they could, even if they ask the same data source or same data point, they could be accessing different data locations for that data. Does that make sense?
Yeah.
I have 2 questions. Can you talk about Storm? And maybe I missed one of the slides of what Storm is. And then the second question is, what do you mean by integration testing?
Okay. So initially, first with Storm. So Storm came about. Storm was released by this guy Nathan Mars. He joined Twitter sometime after, or Twitter acquired his company. But basically, Storm came about. MapReduce was always a batch processing system, never real time. So there was always this question, how do we have some kind of real time ability to real time insight into our data? So Storm was basically built as this thing like, rather than processing all of your data at one time, say at 5 in the evening or 6 in the evening, why not we get chunks of data? So every time you especially for web logs, it's very good for your logs. Whenever your logs come in, you can actually take your logs as soon as they come in. You can make some kind of aggregation of it. It may not be the best aggregation, it may not be the best calculation, but you can make some kind of you can deduce some kind of knowledge from it. But that knowledge you can actually use to make some kind of real-time decisions. So what you would do is that you take this chunks of data that either come in over periods of time, you take that and make some kind of decisions, and then you use that for your real-time initiatives. But then you also take that data and you give it to MapReduce. So MapReduce can combine that data along with what's historical and bring about the real averages or the real aggregates and give that information to you. So you can actually do, so that's how the Storm Hadoop relationship began. The Hadoop was basically, Storm was basically this real-time or smaller chunk data sources that you have that you want to process and get more information about it in real time. Integration testing, this was basically because Hadoop is not just one. I mean, Hadoop. When they say Hadoop, people usually mean all the tools around Hadoop. So Hive, Scoop, Flume, so on and so forth. Even though Hadoop in reality just means HDFS and MapReduce, but when they talk about Hadoop, they always talk about the entire ecosystem. So what happened was that when you release Hadoop, you just can't release Hadoop. You got to release everything else around it. So you got to do a full integration testing of all the tools within the system just to ensure compatibility. So Flume, Scope, HBase, Chakwa, Avro, everything involved integration testing. So this is basically said that they did a complete end-to-end testing of all the tools in the ecosystem and ensured that everything is compatible. There's nothing's going to break in the middle. You don't have to put some data in Avro and suddenly breaks in HDFS. Everything is compatible. Last credits on HotOnWorks, Yahoo. If I email me at sawj@yahoo.com, you can find me on Twitter or LinkedIn. Thank you for having me in this presentation. And if you have any questions, please come and see me after.